Hi, everybody. This is our lecture notes for Wednesday, August 26th. This is for those of you that were unable to attend our live class today on Wednesday. All right, so what I did is I went over our typical schedule for a week in physics. Let me pull that up. While I'm doing this, Schoology conferences wasn't letting me record like I was told that it would, so I'm having to do this one as a video like I normally would for the Monday and Tuesday videos. So again, I went over our typical weekly schedule. Right, Mondays and Tuesdays we have video lectures. And when you open the folder up, you'll see a video here. I'm going to switch this around. When I put this in before, I put some notes down below the video, the blank notes below the video. This is to aid you in taking notes. So I'll put the blank notes or the guided notes template above the video in the future, so you know that that's what you can use to aid you in taking notes. Now you can print that out if you if you have the ability to print things out, take your notes on there. That'll help, and then just have put your printed notes in a binder. Or you can just use that as an aid while you're taking your own notes. If you can't print it out, use that as an aid as you're taking your own notes on a piece of paper, so that you can then store that in a binder. Or your third option is just don't even worry about it. Don't do either one of those, but I will have the guided notes completed, and you can then save that off into your Google Drive for your school. If you want to keep your notes all electronic, that's probably a good idea as well. All right, so again, just a bit of that. So we'll have some blank guided notes for you to fill out. We'll have a video. I might have some worksheets and stuff underneath. I'll have completed guided notes underneath here for those of you that can't print. And then below that, the final thing will be our quiz on that video. Make sure you take that quiz and then hit submit at the end. All right, so that's on Monday and Tuesdays. Wednesdays, days like today, that's where I have a live class. We're going to do a quick review of any of our Monday and Tuesday video lectures, ask what questions people have, trying to make sure everybody's comfortable with the material. This is the primary way I want you to get your participation points, is attending the live Wednesday classes. If you can't, then the next option for you is to attend the Thursday office hours. So let me talk about Thursdays now. So if you're looking at Thursday, oftentimes I'll have I'll do a lab and I'll video it. Or I'll do a demo and I'll video it, and I'll have that pasted here in the top of your Thursday folder. Below that, a reminder that Thursdays are office hour days. Kind of think of it as if you were in school, I'd be sitting in my classroom all day like normal, but you can pop in whenever you have some availability. Definitely during your normal class time, I'll be available. If you do join, try to join me that way. Please make sure this will be done via Schoology conferences. When you join in, when you're available and join in, please use your audio to tell me that you're there. I might be on a different screen. So, and just say, hey, Dr. Yates, and then I'll know to switch over and join you on the conference. Again, this is twofold. It's to help answer any questions you might have. And also, if you were unable to attend Wednesday, here's your second way to get your participation points. If you are unable to attend either Wednesday or Thursday, I need you to tell me ahead of time so we can make some arrangements. So we do have a chance to talk. Make sure you're on board. You have no questions. Make sure you're positioned to succeed and do well on the Friday quiz. Okay, and then the final part on Thursdays is our participation points quiz. It'll be the same every week, and it'll have one question. That one question is, how did you earn your participation points? If you came to the Wednesday lecture, you're going to put the A in here. If you came to office hours, you'll put the B in here. If you made arrangements for me ahead of time to work with me to make sure that you're comfortable and on the material, then you'll put a C in here. Make sure you hit submit every time you take a quiz. All right, so that'll take us to Friday. Friday, we'll have our quiz. A couple things about the quiz. The content of the quiz will be over whatever we had in our video lectures Monday and Tuesday, and any lab or demo video that we have on Thursday. So all three of those have content that could be on your Friday quiz. You will need to take your Monday lecture notes quiz, your Tuesday lecture notes quiz, and finish your Thursday participation points quiz before you'll even be able to see the Friday notes, the Friday quiz. Okay, so you got to do those 3 things first before I'll open up the Friday quiz. That's to make sure that you're prepared for success. I don't want you taking the quiz if you haven't looked at the material. So let's see. The other thing, the Friday quiz will be open from 7:25 to 1:25, our normal school hours. If you cannot take it during that time, please make arrangements with me ahead of time so that we can find some time for you to take it over the weekend. I do need these done by Monday morning. I need you to keep pace with me, and this is one way I can help you from falling behind. Okay. So that was what we talked about. We talked about our weekly schedule. I then talked a little bit about the scientific method, how that it is iterative, right? We'll come up with our hypothesis, and then we'll do a test or an experiment on it. If we find that it does not support our hypothesis, then we got to circle back and make a new hypothesis, revise it with the information that we learned from our experiment. Eventually, we're going to get to a point where our experiments will support our hypothesis, at which point then typically that's when a scientist would publish things or share their findings. Other people then would try to see if they can get the same results doing the same experiment or test your hypothesis in a different way with a different experiment. Either way, the whole goal is to try to do more experiments to support your hypothesis. Right? Then we get down to the part, if those experiments do support your hypothesis, right, then it's now no longer a hypothesis. We have data to back it up. We have experimental evidence to back it up. And at that point, we consider it a theory. After that point, then it's a matter of now we got to figure out how do we apply it. Right now, some research is very basic. For example, the stuff I was doing with electrons, shooting them into nuclei, having them hit a proton or neutron, and then flipping the quark that was inside that proton or neutron. That has no applications for a long, long time in the future, but it does help us have a basic understanding, which then may lead to something else as we keep progressing. You can think of some things that do have quick applicability. Back in the 1950s, when we had electronics, some of you might have seen an old TV. They had vacuum tubes. These things are about like this big. They had these big vacuum tubes to power the TV. But back in the 1950s, some scientists at Bell Lab were trying to figure out a better way of doing it, and they ended up creating a little device called a transistor, which then has morphed and become part of our integrated circuits, our integrated chips, which then form the basis of just about every electronic thing we use today, from phones to computers to televisions, you name it. It's got that kind of application. So there was an example, some research, some development, some application, and boom, it benefited society very quickly. Tuesday, getting comfortable with the metric system. This was really just understanding that the metric system's better than English because it's nice and reasonable, right? You have a meter, 10 meters gives you a decameter, 10 decameters gives you a hectometer, 10 hectometers gives you a kilometer, right? So it's all moving by 10. And if you remember that stair step kind of a picture, we had the kilogram at the top, then we had the hectogram, the kilo meaning 1,000, hecta meaning 100, deca meaning 10, meter being the one in the middle, our base unit, then deci meaning 1/10, centi meaning 1/100, and milli meaning 1/1000. So we kind of had that stair step, and you had to remember that if you wanted to convert from a meter to kilometer, remember you had to go 3 steps to the left, right, to get from a meter to a kilometer. So that means you got to move your decimal, right? If I tell you I have 1 kilometer, I've got to move my decimal over 3 places, so it'd be 0.001 kilometers. That's the nice thing with conversions in the metric system, right? So that's the key thing kind of there, is just how to move moving the decimals around as you go from kilo to hecta, or let's say hecta to deci, just which way, how many steps did you go and which way did you go to get there? And that's how you move your decimal point. That was pretty much it for the metric system stuff as well. Then tomorrow we will do, of course, we'll do a demo, and then Friday for our quiz. All right, so that's all I had for you guys today. Hope things are going well, and take care. Bye-bye.